Good morning. We want to rewrite quadratic equations into graphing or vertex form by completing the square. So when we have an equation that starts out in this standard form, y equals ax squared plus bx plus c, that's what we have here today, x squared minus 10x minus 7. If we want to rewrite it in graphing form, we also sometimes call that vertex form. Y equals a x minus h squared plus k. We find this form really useful because h and k are the vertex of our parabola. It really makes it very fast to go ahead and graph. What we're going to do is we're going to use completing the square to get this part of our form right here. Notice we have a binomial, we have a term, squared. And so completing the square is going to allow us to do that. So when we're working to complete the square with our starting quadratic equation, we're just going to start by working with the terms that have the x's in them, the x squared minus 10x. And we're going to go ahead and use those terms to go ahead and complete the square with just x squared minus 10x. So we build our generic rectangle. We put x squared in the bottom left-hand corner. That minus 10x, we want to split up between these two boxes of our generic rectangle. And we want to split it exactly in half. So we put minus 5x in one and minus 5x in the other. And the signs are really important because this is a minus 10x. I have to make sure to put a minus 5 in each of those. So the outside of my generic rectangle, I need an x and an x here so that they multiply to give me that x squared on the inside. And I have negative 5 and negative 5. Because we split it exactly in half, notice the length and the width now match. That's what makes it a square. This will also allow us to see what it is we would need to complete that square. Well, negative 5 times negative 5 gives me a positive 25. That's what we're going to need to have a complete square, right? If we had a plus 25 on here, we could rewrite that as x minus 5 squared. That's the factored form, and that's my length times my width. So now that I know what I need, I can go back to my original equation up here, f of x equals x squared minus 10x. I want to add a 25. However, I can't just add 25. I'm going to change the value of the equation. So right next to that, I'm going to actually subtract 25. This way, if I add 25 and subtract 25 right next to each other, that basically adds up to 0. I haven't changed the balance of the equation. And then I also need to bring down that minus 7 at the end. So notice this is what we've done to the equation. And what that's allowed us to do, now we have x squared minus 10x plus 25. So that first part that's now a complete square, I can rewrite as x minus 5 squared as the product. And then I just need to combine the minus 25 and the minus 7, and I get minus 32. So here, I now have my equation in graphing or vertex form. And here's what I know about this equation. My vertex is located at positive 5, negative 32. Right? Those came from, here's my x coordinate right here. And it's always the opposite of what you see. This is x minus 5, which makes my x coordinate a plus 5. And minus 32, exactly what you see on the outside, that's your y coordinate. The other thing we sometimes want is the axis of symmetry. And so what I know about this parabola right now, I know it opens upwards because its a value is positive 1. And I knew that because that's the coefficient in front of the x squared. And it's also, there's a 1 out front here, even though we don't see it. I know my vertex is here at 5, negative 32. There's a negative in there. And then finally, my axis of symmetry is going to be this vertical line that goes right through the vertex. And a vertical line always has the equation x equals some number. And in this case, it's x equals 5. Every single point on that line has an x coordinate of 5. And it also always matches the x coordinate of my vertex. So we can go ahead and add that one last thing, that axis of symmetry is x equals 5. So by rewriting it in graphing form, it's going to be much faster to graph. I can very easily see the vertex and the axis of symmetry.